Hello everyone, I'm Amani Bird. I'm a first year biochemistry major from Westchester, Pennsylvania.
I'm Samantha Mason. I'm a first year biochemistry major from Waldorf, Maryland.
My name is Naya Jones. I'm a first year biochemistry major from Kansas City.
And my name is Chico Iganu. I'm a first year biochem major from Newark, Delaware.
So our research question was, how does the general change in temperature over the fall season influence or change biodiversity? And so what is biodiversity? Biodiversity is both abundance and richness, which is something we're looking at, of birds of prey. So what we define as birds of prey or raptors are hyper-carnivorous bird species that actively hunt for their food. Some of the food that they look for are bugs, nuts, fish, etc. And the abundance of these resources changes based on temperature. Typically, as the weather gets colder, these resources diminish, and that is what causes them to migrate.
Okay, and then for how we conducted our experiment, to start conducting this experiment, we used data from the Hawks Sanctuary Hawk Count site. The Hawk Sanctuary is located in Berks/Schuylkill counties in Pennsylvania. Essentially, how the data was collected was bird watchers would go out with binoculars and record which sightings they saw on which days. For each day of data between August 15th to December 15th, the day's total raptor counts were recorded along with the weather and observations start and end time. After the data was collected from the Hawks Count website, we transferred the information to Microsoft Excel, where we conducted charts for each month, week, and other expressions of the data. In Excel, the charts were organized from minimum, average, maximum, standard deviation, standard error, and median. The charts were then turned into graphs for further analysis, and the graphs and charts were then compared to the average temperatures throughout each month, which were also recorded to get to our end results. Oh, and the data collection and methods flowchart. So essentially, we have that depicted right here. And if anybody else would like to elaborate further on this, that would be great.
The flowchart basically just shows how, firstly, we took the information from the website, we recorded that, and then we put it into Excel, and then that's how we got all of the graphs that are in our poster here. So that just is a visualization of the process.
After doing our research and collecting our data, our results came out to support our hypothesis that biodiversity is the lowest during colder months. As seen below, our research table and our average temperature graphs demonstrate warmer months somewhat corresponding with the high species abundance. When comparing the warmest month, which was September, to the coldest month, which was December, we found that the coldest month has a lower overall abundance. As followed through the graphs, our average temperature for the months observed is 18.7 degrees Celsius, which resulted in the most abundant species change each month. This is believed to be due to varied periods of time in which migratory birds accompanied the area.
So, let's reference the very first chart. Let's do September. So for the abundance in September, the most abundant bird was, I believe, the broad-winged hawk, and that was the most abundant for the entire month of September. And I think September had, or I know that September had the most, the highest abundance overall out of all the months in our sample. And you can see that the temperature varied throughout the month, and there was really no constant temperature. So our area was pretty good to observe in terms of not having a constant temperature, so we could really truly see if temperature had effect, because if it stayed the same, then that would definitely impact our data, and as well as the answer to our research question. For October, so for the month of October, the sharp-shinned hawk was the most abundant, and the temperature doesn't vary as much. So in September, there were definitely some spikes at almost around 20 degrees Celsius, and for the month of October, it was a bit more constant. And we found that when looking at September and October, the birds that were the most abundant were different, and as well as November, December, and August. So each month had a different bird that was the most abundant, which we believe is due to the change in temperature. So, sorry.
No, you're good. For the month of November, the temperature throughout November stayed consistent, with the average temperature for November being 17 degrees Celsius. And for the abundance for November, the numbers of species stay consistent as well, with the most abundant species of bird being the red-tailed hawk.
Okay, so for the half months that we did analyze, we can start by briefly going over the month of August, and then we can get into the half month of December.
So, not featured on the graphs, on the poster, are graphs of the month of August and December, because we found that most of what supported our hypothesis came from the months of September through November. The reason for this being is that for the month of August, there was an overall abundance of only 225 individuals, with not a very high richness. The richness was 12, which compared to other months had 15, or somewhere around there. So there wasn't as much data to pull from. So, and the temperature in August was also much warmer, so the resources for birds were still there, and they had not began to migrate yet. So we didn't begin to see the migration and species turnover until September and October.
Okay, and then finally for the month of December, which was also a half month, I just wanted to highlight a few things about the month because it is a very unique month. The abundance in the month of December is at an all-time low with 152, and considering that both August and December had the same amount of days recorded, both being half months, it just kind of shows the disparity in the abundance of bird species. As far as richness goes, the richness is at an all-time low as well. And as far as bird sightings in general, this we believe is largely due to the colder temperatures. The average temperature in the half month of August recorded was 32 degrees to 25.6 degrees Celsius, while in December, the high was 12.2 degrees Celsius, and the low was negative 7.8 degrees Celsius. So, being as though there was a lower average temperature during the months recorded, that could be the reason for the sudden drop in abundance as well as richness. The birds that were less likely to eat, or the birds that were most frequently spotted in the month of December, could largely be due to the fact that they are less sensitive to temperature. As far as colder temperatures, they can survive longer. But overall, that is pretty much all for the month of December and what we found as far as temperature drops.
So to wrap things up with, I'm sorry, go ahead.
If we were to conduct this research again, some things that we would change would be including regressions as well as scatter plots to show a better relationship between the temperature and the species that we were seeing. That way there could have been a visual for you all to see, as well as looking beyond the month of December to have a better amount of data. So perhaps looking from September 1st to January 31st would have given us the most accurate depiction of the migration that was happening at our site.
So to wrap things up with a discussion, we in our research, we made sure to pay special attention to the specific species of birds that were the most and least abundant, as you can see by the abundance chart for the abundance graphs for the 3 months in the fall. And hawk migration is a huge factor that we think plays a role in why certain birds are more abundant during one time or 1 month than another. And so when we look at migration, we looked at why these specific species migrate to this specific area, or why this area would be where they are coming to or where they're leaving from. And we also took into account whether or not other factors besides migration impacted the total abundance for birds for each month. So all of these questions aided us in making sense out of the data presented here. So for the acknowledgements, this project is funded by the NSF grant, and we'd like to thank Dr. Sean T. Dash for guiding us through this project. Thank you.